So currently we are in an R studio. And in R studio, we have set our working directory where we have a one file named blood2.csv. This file is going to have a data of the three different level of the dose treatment to control the systolic blood pressure. So let's load that data by using the read.csv function and creating a one variable name as sample underscore data. We hope so that you guys will be quite familiar with this code. So we are not going to explain that code right now here. We are just going to write it down. After writing this piece of code, let's run it. And when you will run it, then look at the console and look at the environment tab. In the environment tab, you can see that there are the 5 observation and the 4 variable in our loaded data. Let's click on this sample underscore data in the environment tab and let's see the data. When you will click here, then you can see the data. Now, if you note it here, then this data is actually in a wider form. And in this form, we cannot apply the one-way Anova on it. We need to convert it into the longer form. So, before applying the Anova, we will carry out the transformation to convert this wider format of the data to the longer format of the data. So let's see that how we can do that. We are back to our coding space. Now here, let's first check out the structure of our data by using the str function. When you will run this piece of code, then look at the console. In the console, we are going to have an idea that there are the 4 variables. The first variable is a patient, the second variable is a low, the third variable is medium, and the fourth variable is high. And there are total 5 observations in each variable or the column. Now let's convert it into the long format of the data. To carry out that conversion, we will use a tidyr library. So we will first call the tidyr library by typing the library and then tidyr. After typing this piece of code, let's run it. And when you will run it, if you are not going to find out any issue or any error in the console, it means that the tidyr library is now available for you. Now in the tidyr library, we are going to use a one function pivot underscore long. So let's use that function to carry out the transformation. Let's create a new variable name named data underscore long. And let's give a sign of equality in R and use a function pivot underscore longer. After typing this function, let's come inside the parentheses and write down the name of the variable that is holding our wider format of the data. And that name of that variable is sample underscore data. After typing that name of the variable, we will give the comma, and after giving a comma, we will write down the calls equal to define the name of the columns in which we are interested. We will give first the C. After typing the C, we will come inside the parentheses and then we will write down the name of the columns. So as you know that there are the 3 columns in our wider format of the data in which we are interested. And these 3 column names you can find out in the console. That's a low, medium, and high. So let's type the low, medium, and high. After typing the name of the columns in a wider format of the data, come outside the parentheses and then give a comma. After giving the comma, let's use another argument, names2. After writing the names2, let's give a sign of equality and then give the comma inverted comma. In comma inverted comma, write down the name of a new column in which you want to store the low, medium, and high names. And let's name it as a group. After this, come outside the comma inverted comma and then give a 1 comma. After giving a comma, let's use another argument, values2. After typing the values2, give a sign of equality and then give a comma inverted comma. And in with comma inverted comma, let's write down the name of a second column where we want to store the values of our groups. And let's name it as BP. After typing this piece of code, let's come outside the parentheses and let's run it. When you will run it, then look at the console. You are not going to find out any error message. It means that your code is successfully executed. Furthermore, look at the environment tab. In the environment tab, the data underscore long variable is created with the 15 observations and the 3 variables. Let's click on it. When you will click on it, then this data will appear in front of you. Now look at it here. Now the data format is changed successfully. Now this is not in a wider form, this is basically in a long form. And now this is actually suitable for the one-way Anova analysis. Let's come back to the coding space. In the coding space, let's check the structure of our data set that we have just created. Let's type the str, and after typing the str, write down data underscore long. Let's run this piece of code. When you will run this piece of code, then look at the console for the output. In the console, you are going to find out the name of the 3 columns that is present in data underscore long. The first one is a patient, the second one is a group, and the third one is a BP. The patient is basically holding the numeric data. As we can see it here that int is written. The int stands for the integer. The group is holding the character data. As you can see it here that there is chr is written, while the BP column is holding the numeric data as int is written there. Now keep it into mind that in the groups, there is basically the 3 different factors that are present: low, medium, and high. R has mistakenly understood these 3 different levels as a characters. So before applying the Anova, this is pretty important to rectify this mistake. And to rectify this mistake, what we are going to do, we are going to write down just one single line of the code to rectify this mistake. How we will write that code? Let's have a look here. First, we are going to write down the name of the variable that is holding the data, and then we will give the $sign. And after giving a $sign, we will select the column where we want to rectify the mistake. Right now, it's a group column. So we will select the group. Then we will give the sign of equality. And then we will write as.factor. By typing as.factor, we are basically letting the R know that R, you are mistaken. These are not the character values in the group column. It's basically the factor values. So please treat them as a factor. After this, we will give the parentheses. And after giving the parentheses, we will write down the name of the variable that is holding our data once again. And we will give a $sign. And then we will select the group in which we are interested. After writing this very simple piece of the code, let's run it. When you will run it, then look at the console. No error message has appeared. It means that our code is successfully executed. Now let's check the structure of the dataset once again by typing str data underscore long. Run this piece of code and look at the console. And in the console, now if you note it here that in front of the group, not the character is written, it's a factor that is written. And you can see that now the R has rectified mistake. Now R is now considering the values in the group column as a factor, not as a characters. So please keep it in mind that this is pretty important when you are going to apply the Anova here. Great. Now our dataset is ready. And now this is time to apply the one-way Anova. To apply the Anova, let's first call the BSDA library. To call the BSDA library, we will type the library and then we will write down BSDA. After typing this piece of code, let's run it. Now our BSDA library is activated. Now let's create a variable named test and then give a sign of equality. And now we are going to call the AOV function. This function will primarily perform the one-way Anova for us. Then give a parenthesis. Now in the parenthesis, we have to define the name of the column that will have the numeric values. And as you know it very well, that the name of the column which is having the numeric value is BP. So we will type the BP here. After this, we will give the tilted sign. And after giving a tilted sign, now we will write down the name of the column that will have our groups. And we have set that name of the column as a group. After typing the name of the column that will have our groups, then we will give the comma. And after giving the comma, we will use a data argument to specify in which variable we have these two columns. And you know that it's data_long variable that will have these two columns. After typing this very simple piece of code, let's run it. When you will run it, then look at the console and as well as your environment tab. In the environment tab, the test variable is created. It's a list of 13. Please don't worry about the list of 13 right now. In the console, we didn't get any error message. It means that our test is successfully executed. Now we want to see the results. And to see the results, we are going to use the summary function this time. So we will type summary. And then within a summary, we will write down the name of the variable which is having our test results. And name of that variable is test. So let's run it. And when you will run it, then look at the console. And in the console, you are actually going to have the values. The values includes the degree of freedom, sum of square, mean square, F value, and the P value. And by the way, right now we are interested here only the two values to interpret the results. And what does it mean by the interpretation of the results? Interpretation of results means that either rejection or acceptance of our null hypothesis. The F value is 53.1, while the P value is 1.09 multiplied by 10 raised to the power 6. What the F value and the P value is letting you know at the 0.05 significance level? Now, if you compare the P value with the 0.05, then you are going to find it out that this P value is pretty small than 0.05. Now, in this case, what you are going to do? Do you remember? Obviously, you are going to reject the null hypothesis. Have a look here. Along with the P values, you are going to find out the 3 stars. Now, what these 3 stars are letting you know? If you find out below the residual line, then you are going to find out the significance code. And in this significance code line, you are going to find out the 3 star with a 0, 2 stars with a 0.01, 1 star with a 0.1, and no star with 0.05, and 0.1 and the 1. Now, what these stars means and what are these values? The 0 means that 100% level of significance and the alpha value is 0. The 0.01 means that 99% level of significance. The 0.01 means that 99.9% level of significance and the alpha value of 0.01. 0.01 basically letting you know the 99% level of significance and the 0.01 alpha value. 0.05 is letting you know 95% level of significance and the alpha value of 0.05. While the 0.1 is letting you know the 90% level of significance and the 0.1 alpha value. If you are going to find out the 3 stars with your P value, it means that your results are very, very reliable. If you are going to find it out only the 2 stars, it means that yes, these are reliable up to the 0.01 alpha value. But if you are going to below than the 0.01 alpha value, then your null hypothesis could be accepted. If you're going to find out the 1 star along with the P value, it means that you should be confident up to the 0.01 alpha value. If you're not going to find out any star with the P value, it means that your results are only significant up to 0.05 alpha value. Below this, they are insignificant. We hope so that these points are clear to you. In a very simple words, 3 star means very reliable results. And no star means that results could be insignificant, or there is a higher chance of error. We hope so that these points are clear to you. So this is an end of a one-way ANOVA. In the next video tutorial, we will start talking about the two-way ANOVA. We hope so that this will be interesting for you. If you have any question or any concerns, then please do let us know. We will always welcome your questions, suggestions, and critique. It's very valuable for us.